We shall now move on to the next chapter, thermodynamics. We know that chemical energy is stored in the molecules. This energy may be released as heat energy during chemical reactions, or chemical energy may be used to do mechanical work, or it may be used to provide electrical energy. Thus, we come to know that chemical energy is getting transformed into heat energy or electrical energy. That is, one form of energy is getting transformed to another form of energy. So, thermodynamics can be considered as the study of energy transformations. The laws of thermodynamics deal with energy changes of macroscopic systems. Macroscopic systems are those systems consisting of a large number of molecules. It is based on the initial and the final states of a system undergoing change. Laws of thermodynamics apply only when a system is in equilibrium state or it moves from one equilibrium state to another equilibrium state. Consider properties like pressure and temperature. These properties are called macroscopic properties. They do not change with time for a system in equilibrium state. Let us try to know about the thermodynamic terms like system, surroundings and universe. What is meant by a system? It is that part of the universe in which observations are made. Now what about surroundings? Surroundings include everything other than the system. System plus surroundings constitutes the universe. Let us now try to know about the three different types of system known as open system, closed system and isolated system. What is meant by an open system? A system which can exchange both energy and matter with the surroundings is known as an open system. Water taken in a beaker can be considered as an example of open system. Now consider closed system. It is a system which can exchange energy but not matter with the surroundings. Suppose if we consider water taken in a beaker, and if the beaker is covered with a lid, it can be taken as an example of closed system. Now consider isolated system. A system which cannot exchange both matter and energy with the surroundings is known as an isolated system. Water taken in a thermos flask or insulated flask can be considered as an example of isolated system. So these are the three different types of system: open, closed and isolated system. State variables or state functions. A system must be described by specifying pressure, volume, temperature and composition of the system. Suppose we have a system in which a change has to be carried out. So before carrying out the change, the system will be in a particular state which can be called as the initial state. And after carrying out the change, the system will be brought to another state, and that can be considered as the final state of the system. So how can we describe the system? By specifying properties like pressure, temperature or volume before and after the change. We can describe the state of a gas by quoting its pressure, volume, temperature and amount. So variables like pressure, volume, temperature are called as state variables. Why are they called as state variables? Because their values depend only on the state of the system, and these variables do not depend on how it is reached. So variables like pressure, volume, temperature are called as state variables or state functions. Internal energy U as a state function. Internal energy is denoted by the letter U, and it can be considered as a state function. We know that a state function is one which depends only on the state of the system and not on the path followed. Now what is meant by internal energy? It is the total energy of the system. The sum of the different forms of energy associated with the system can be called as internal energy. The different forms of energy can be electrical, chemical, mechanical or any other type of energy. It is found that internal energy changes when heat passes into the system or when heat passes out of the system. Internal energy changes when work is done on the system or when work is done by the system. It is also found that internal energy changes when matter enters the system or leaves the system. So now let us see how a change in internal energy can be brought about in a system by doing work. What is the system to be considered here? It is some quantity of water taken in a thermos flask. Since water is taken in a thermos flask, there will not be any exchange of heat between the system and the surroundings. It means heat cannot enter into the system or heat cannot leave the system. Since there is no exchange of heat between the system and the surroundings, it can be considered as an adiabatic system. The manner in which the state of a system may be changed is known as an adiabatic process. Since the change is brought about in an adiabatic system, the process is known as adiabatic process. So here, before doing the work, the system will be in its initial state. And after doing the work, the system will be brought to a final state. So the manner in which the state of a system may be changed, that is from the initial state to the final state, it can be called as an adiabatic process.